Hi, welcome to Wise Guys. Uniform circular motion. This is practice question 2. This I will show you when the centripetal force is gravity and the tension. So from this picture we can see this looks like a pendulum. A small ball is hanging with the string. The mass is 0.2 kilogram. The length of the string is 1 meter. At the bottom, VB means at the bottom, when it is swing back forth, at the bottom, this situation, the velocity is 4.43 meter per second. Looking for the tension. This is tension force. As we know, by a free body diagram, the small ball exerted at two forces. One is gravity. The other is tension force, right? So when the small ball is swing back forth at bottom, this situation, so we can say, because we're given the instantaneous velocity, so we can say at this situation, even this situation when the small ball is doing circular motion back forth, this is for all the motion is not uniform because they getting faster and to the bottom, then getting slow. But we still can using the centripetal force formula and the centripetal acceleration formula to calculate the tension, because we use at this instant the velocity is 4.43. That's why at this situation, what is centripetal force? The centripetal force is the net force of tension force and the gravity. So you can first write tension force minus gravity equals m times v squared over r. This r actually is the length of string to the center of ball. That's why we say L. So the tension and the gravity is one is up, one is down, and the center is at this point, right? The circular motion, the center is over here. That's why the tension force subtract the gravity. This is the net force. And then we're looking for tension force, so we can move Fg to the other side plus mv squared over L. And this situation gives us the Fg equals mg and the plus mv squared over L. So we got tension force. We can pull m as common fact. We have g plus v squared over L. Now, then we can plug number in. We got m is 0.200 kilogram multiplied 9.8 meter per second square if we carry the unit. And the top is v squared is 4.43 meter per second square divided L is 1 meter. Okay? Then we got the tension force. We can use calculate to do this question. We say you got 4.43 square, and equal divided 1, still this one, and the plus 9.8 equal, then multiply 0.2, we got the answer is 5.88 Newton. So this is tension force. And the next question is, if the small ball, if this ball doing circular motion at this position, and this is a theta equals 60, this one equals 60 degrees, what is the tension at this time? So for free body diagram, we still can draw, this is the gravity, this is the tension force, and this situation we can see the centripetal force, as we know, always point to the center, always has to point to the center. That's why we need looking for the net force on the direction of point to the center, because the tension already point to the center, but Fg is not. That's why we need to get the component for Fg, which we can get component. One is on the direction of radius, the other is the tangent to the curve. So this one gives us two components. This is a, let's say, if F1, this is the F2 for easy. Okay, F1 is on the direction to the center, which is we need this one. But what about this one? Because this one, F2, is tangent, which is perpendicular to the radius. So this force is not doing any contribution to the radius. So this one, the F2, just to make accelerating at the tangent. That's why I already said this question just you need use instantaneous, because in this situation you're given the instantaneous velocity is 3.13 meter per second at this moment. That's why we use v theta. Now theta equals 60, because every moment the velocity is different, but we use this formula to solve instantaneously. So we only need to find F1. So F1 equals, because this is 60, this is a vertical down, this is vertical down. So that's why these two angles are equal, 60 and 60. So F1 is adjacent to the angle. That's why F1 equals Fg. Fg in this triangle is hypotenuse times cosine 60, right? Then we get mg is 0.200 kilogram multiplied 9.8 meter per second square, and the cosine 60 is 0.5. Here. That's why we got F1 equals to 0.2 multiplied 0.1, which is half of 0.2, which is 0.1. Then you got F1 is 0.98 Newton. So this is the part of centripetal force we need. Now, after that, we still can write the centripetal force equals Ft minus F1, right? So we have Ft minus F1, the centripetal force equals m times v squared over L, which is the radius. So we can move this one, F1 to the other side. Ft equals F1 plus mv squared over L. F1 is 0.98 Newton plus 0.200 kilogram multiply V squared is 3.13 square. This is meter per second. I'm not write this one. I can write this one on the top. And divided area is 1.00 meter. Okay, so that's why we got the Ft equals 0.98 plus this one is 3.13 square. Let's calculate this one. 3.13 square. And equal this one, divided 1, still same, and then multiply 0.2, we got 1.96, and then plus 0.98 give us 2.94 Newton. So at this moment, the tension force is 2.94 Newton. So this will show you at this situation, so we need to get the component Fg. Then calculate the tension force. Thank you.